Hello, everyone. Let's get started. Please download Laboratory 30 from Blackboard. And today we are going to learn multiple regression model. And first of all, I need to tell you next lab would be the last one in this semester. And on Friday, I will introduce you the last lab and the introductions of your projects. Okay. All right. So as usual, please run the first script to identify your host name, username, and current information. And the next one is please input your name, a number, title, and date. Today we are going to use another CSV file to construct a linear regression model. First of all, you need to import the necessary packages, NumPy, pandas, Seaborn. This is a plotting package, statistics, math, and matplotlib. Okay, and perhaps you will have some problems when you import the Seaborn. So if you haven't installed the Seaborn package, you need to use pip install to install it first. But I think most of you has already installed it because we have used it like twice or three times in the previous labs. Okay. So if you have errors about importing Seaborn, you need to use this way. Okay. Let me copy. Okay. Next one, you need to download the CA California housing data CSV file, and you can use the requests URL link and get them and open a new file and install and save it into a new file. Okay, run it, and at last here you can refresh it. Then you will see a CA housing, and in this CSV file there are 9 columns. So you see the last one is very important. It's about the average house value. Is something we want to predict, and the first 8 columns, they are all features. Like here, median family income, house age, average rooms, average bedrooms, population, average occupation, and latitude, longitude. And the last one is something we'll predict. Okay, so after you download it, you need to read this data file into a data frame. Okay, read into a data frame. Use the pandas.read CSV, right? And next one, use the describe to show the file summary descriptions about each column, the count, mean value, standard deviation, minimum and maximum, about all the average, right? So you see, it's pretty large, right? It's 20,640 rows, and the mean values about that. So, and next one, we want to do the pre-processing. Perhaps there are some empty values in the CSV file. It happens a lot, right? So after loading the data, it's a good practice to see if there are any missing values in this data set. So we can use this function, is now, and some of the numbers to check if there are any missing values. And you see here, they are all zeros. So it's a good data set, right? So because for now, there are no missing values. Okay, so, okay, any questions so far? Or do you have any errors with run the cells? All right, next one, you need to do the data analysis. We want to plot a distribution of a target variable. Target variable is last one, right? Average house value depending on latitude and longitude. So in this figure, we use a scatter plot, but not a regular scatter plot. For instance, here we set figure, and then latitude as the x-axis, y-axis as housing longitude, and then we use 2 different variables. Actually, here we use a housing, color is housing, and here S is population, use a population to show that. And we also set a color bar so we can run it, show the results, okay? So you see here, latitude, longitude, right? Latitude and longitude, and the color about the values. So if they are higher, then it would be the like orange or yellow color, and if they are lower, then it's dark blue. So and you can set the housing population. Actually, the population here is there's no units about the population. I think perhaps it's 1,000 or 10,000. I'm not sure, but it doesn't matter. So we only want to know the density of the population and the house values, right? So after you can use it to show that it's a little bit fancy, right? So you see there's a color bar, so you can check the different colors. The color means the density, right? And if you use longitude and latitude, so it will looks like a map because it's just the map, right? So here it's sort of like a California, so it's like a California map, and notice the high value homes along the coast. So here you see I think it's San Francisco, right? Bay Area and Los Angeles, they are very high and got cheaper as one moves inland. So you can read them from this figure, from this scatter plot. So it's a better one to show how to use the scatter plot. All right. Yeah. So what is purpose? In split down. Yeah. I think so. Yes, I think so. Because for now, I think in this one, I don't know. We don't know the units of the population, right? So they are all numbers. They are only the numbers. So I think they are just use this division by 100 to make it like smaller, to scale it down. Yeah, you're correct. I think so. Yeah. If there are some other units, perhaps it's not 100, it's 1,000. You can divide it by 1,000 or divided by other numbers to scale it down. Yeah. Thank you. Yeah. All right. So next one is about the correlation map. So it's also an important feature to show the relationships between the variables. So the script here produce a correlation map, prints off diagonal correlation mixed terms, and you can learn from here how to draw, because in the previous, in lab 28 or lab 29, when we want to show the correlation matrix, we only use a table, right? Only a table to show the correlation coefficients. But in this way, we can use the number, but we use a different color and use the here off diagonal matrix to show that. Okay, so we use a subplots to multiple subplots, and here mask is used to show, to make it as a figure, right? So you can run it and check the results here. And then in this way, we use a heat map. It's also from the Seaborn, right? This is from Seaborn. As soon as it's Seaborn and heat map to show this one square, we use a square block squares to show the values, right? And from this one, you can check the results. You can check all the correlations, and because you want to predict the last column average house value, so you can just read the last one, right? So you see the correlation number between the average house value and the median income would be 0.69. It's significant, right? Because it's much larger than 0. So compared with the following, this 3, right? So there, this is 0.047. So it's very, very small, right? It's smaller than 0.1. So it's like related to, it's about zero, right? They are all about zero, so they are not significant. So we will think the first three variables, they are significant. So we can use them to predict the average house value. They are highly related to the value of the houses. Okay, so but this is our next step. So the first step would be we want to build a multiple regression model on all of the variables. So here we need to use the statistics models formula. So this one, right? Formula API, SMF, and use the ordinary least squared method to get the multiple linear regression model, something you want to predict. They are all the 8 features and housing, right? And the first line is used to initialize the model, and next one to fit the model, predict the model, and print out the summary. Okay, so you can write, and it is the results. It's a linear regression model. So the model type, method, and correlations, and the intercept, and all the slopes for each variables. Okay, you need to read how to read it. The most important and R squared to show how well it fits the model, it fits your data set. It is about the linear regression model. And you can also print out the parameters. So this is this one, right? Coefficients, the first columns, coefficients. It's also the parameters. So based on that, because it's a linear regression model, so you can write down the equations of the model, right? And the first one would be the intercept, and then plus the second one, slope, and multiply median income, and next one, average rooms, and next one, house age, and blah, blah, blah. So you have 8 variables, so 8 slopes, and multiply 8 variables, and plus intercepts, get the results. It is the equation, right? So any questions so far? Or do you have any errors? Okay, so but here is a question. So here's the question. Some slopes, they are quite small. As we learned from the correlation matrix, to fit a linear regression model, we need to select some features have a high correlation with our dependent variable average house value. So by looking at the correlation matrix, we can check the median income has strong positive relationships with the average house value. So here you can see the first one is high positive correlation, right? Sorry. And the other 2 variables is house age and average rooms. House age and the average rooms. It means the first 3 variables, right? So, and we need to drop populations, and we need to drop all other things because they are quite small. They are not significant. They are about 0, right? So after that, we can train our model, select our model again. In this one, in this new model, we only select the 3 variables, like median income, house age, and average rooms. Okay, so it is today's exercise. You need to build a new model to predict the average house value based on 3 variables: median income, house age, average rooms. So you can use the code from here. All right, so but not so many features, so many variables, only 3. Okay, and after that, you can use the parameters to get the result, to get the slopes and the intercepts. And you need to report the equations of model. So the pattern should look like this one: average house value, intercept, and this is the slope, and slope. 3 variables, 3 slopes, and 1 intercept. Okay, it's about the efficiency of the model. And after that, you need to plot histograms of the average house value. Okay, they are today's exercise. All right, so I need to repeat again. So you need to define a new model based on 3 variables. And after you train this model, please report the equations and plot histograms. Okay, and the next lab is the last lab, and I will also introduce you the projects. I'll give you a brief introduction or some tips about the projects. Okay. All right. So see you on Friday. And if you don't have any other questions, please feel free to leave the meeting. Have a good lunch and have a nice day. Thank you, guys. Okay. What is your question? Oh, projects. What do we need to show exactly? It's a big question. So let me. Where is the projects? All right, let me check. Write 1 quality project. We choose. Okay, let's wait a moment. Let me find it. This one, right? Okay, let me show you. Pair tasks, data equation, data classification. Okay, so classification. So I think that they are all required tasks, right? For the first 3, I think you need. You have done them several times. Data review, you need to do that, and data equations. So you need to download them from here. You need to use the requests to download it, right? And then you need to perform some basic analysis. And after that is a classification model. It's a hardest one. So you need to use the you need to define an algorithm to classify it is good or not. You need to define which feature is significant related to the quality. And after that, you need to determine it is good or not. You need to provide a model. Do you understand what I mean? So at last you need to train a model, and based on this model, we can if you have some inputs, this model will determine or will predict it is a good or not. This model would be your final deliverable. Okay. And yeah, and you also need to evaluate this model by yourself first, and show like it's a good or not, and how to improve your model. Yeah. So yeah, and I will also talk about this classification model on Friday. It is our last lab. Okay. I will tell you more. Yeah, on Friday about this model. Okay. But we have multiple factors. Yes, actually there are multiple factors. That's why here is the big projects, right? But you need to determine if some of them are better, or you can also consider all of them, all of the factors. Okay, and or you can select some significant features or factors. Yeah, so it will related to the quality of your model. So that's why here you need to evaluate your model, okay? Because some of them, they are not good. You need to consider more factors. Perhaps you need to drop some factors. Yeah, so that's why here you need to evaluate. I have to find a pattern. So I'm not sure a pattern is a good concept, but I think it's not a pattern. So you need to find the relationship between the quality and the, let me show you again. So sorry. Okay, this one. So for instance here, it's a CSV file, right? So the last one, the quality will something you want to predict, right? It's just like the average house values into this class. So into this class, the average house value, right? Is something we want to predict. And there are eight factors or 8 features. 1, 2, 3, 4, 5, 6, 7, 8. But not all of them are significant relations, right? So that's why here we want to build a matrix map, and we see actually there are only 3 of them. They are largely affect the average house value, right? So based on that, we think perhaps a model based on these 3 variables would be better. Would be better than this model, okay? So similar to this one, if you consider, I think there's, I think maybe, I'm not sure how many, it's like 12 or 13 factors. So, but not all of them, they are significant, as they are 12. Yeah, not all of them, they're significant. So you need to determine the significant factors first, and then build a linear regression model and evaluate your model, okay? Some of them, they are not relevant, I think. Perhaps they are not relevant, so you need to determine it first, okay? Yeah. All right, so if you don't have further questions, just send me an email, all right? Okay, and okay. Yeah, thank you. Thank you. Have a nice day. You too. Yeah.